여러분, 저 얼굴 많이 부었죠? 어제 라면을 너무 많이 먹었나 봐요. 아, 이럴 때는 운동도 좀 하고 하면 좋은데.
But exercising in a weightless environment isn't easy. Even doing the simplest stretches can make you lose balance. Bars are essential to keep my body in place.
선배, 또 라이브 방송하세요? 오늘 선회 작업 잊어버린 건 아니죠?
헤이, 설마 그걸 있겠니?
여러분, 전 일하러 가겠습니다. 안녕!
This is the International Space Station, a human-made space base located approximately 400 kilometers above Earth. Orbiting Earth at a predetermined altitude, the ISS conducts observations and experiments and also serves as a launch pad for space exploration vehicles. You can observe the weather of each planet up from here. Neptune, a colossal ice giant. Deep within this massive ice planet, it rains diamonds, which are made of crushed carbon atoms. On Jupiter, with an average temperature of minus 150 degrees Celsius, ammonia clouds pour water ice crystals into the planet's atmosphere. Mars, with 95% of its atmosphere composed of carbon dioxide, is known as a frigid and rigid planet. Dust storms, with speed reaching up to 100 kilometers per hour, are frequent on this desert world. And Earth. It's a green planet with its atmosphere composed of mostly nitrogen and oxygen. It's the only planet in the solar system where life exists. The hidden face of Earth can be seen at a glance from space. Earth transforms into different colors depending on the amount of rain, clouds, and winds, as well as the temperature. We call this the weather. From the tiniest raindrop to the gentlest breeze, each seemingly insignificant elements affect the weather, having a tremendous impact on our daily lives. The weather we experience every day is a stark reminder of the pressing climate challenges we face today. Humans long wanted to unravel the mysteries of weather. We have ventured to the heavens, seeking to get a glimpse of the future of our world. The weather has now become a critical indicator of our planet's future, as now is the era of the weather. From space, I would like to talk about the challenges presented by weather, and weather as an indicator of the changing Earth.
My name is Ricky Forbes, and I am a storm chaser. My job is to track and record some of the wildest storms on Earth.
Ricky is a chaser. He has been chasing tornadoes for 11 years now and is live streaming his journey through a video platform. These are mammatus clouds. Mammatus clouds, which resemble cow udders with back-like sacks of vapor hanging beneath, appear when the atmosphere is unstable. It's also a sign of an upcoming tornado.
We have a look here, we're talking about tornado risk, and so you can see, we got going through Texas, Oklahoma, Kansas, Nebraska, and so on. So we got the green at 2%, the red at 5%, and then we got a 10% hatched right there. So what that's telling us, looking down here on the forecast, is that the National Weather Service is telling us that there's a really good chance of really big storms that could produce.
In May 2023, Ricky was engaged in a chase. A storm that developed in southwestern Colorado moved northeastward, producing strong lightning, thunder, and hail. His colleague's car is stuck in the mud.
Whenever you're ready.
Yeah, okay.
There are always unexpected risks that come along the path of chasing Mother Nature. Tornadoes are formed when the warm, moist air on the ground rises rapidly into the atmosphere and clash with the cold air above. They are now close to the tornado.
There we go. On the left, on the left, on the left. It's trying to do something.
Capturing this very moment is the sole purpose of Ricky's chase. The energy-absorbing vortex intensifies, spinning furiously with a long, spiraling tail. Ricky has witnessed tornadoes over 400 times in the past decade, yet each time he is filled with awe.
And they do feel like monsters. They feel like living beings. The air is electric, it's humid, you can feel their hairs starting to stand up, and you start to get underneath it, and you see the blacks and the blues, and it looks like an angry ocean. It starts to swirl up right above you, and the clouds are reaching down like arms reaching out of the sky.
Storm chasers must be able to make quick decisions and move swiftly. He uses a weather app on his cell phone to track the location of the storm in real time. But the eyes that provide him with all the information are located far beyond Earth. Like weather satellites such as ALOS. Since NASA's launch of its first weather satellite in April 1960, weather information has been upgraded to 3 dimensions. The European Space Agency also actively uses satellites.
Very soon after the launch of this first weather satellite, we started to realize that using space as a vantage point for understanding the weather has great advantages, because from space you can basically watch every part of the globe.
Currently, some 160 weather satellites are in operation by various countries around the world. These satellites observe the Earth's atmosphere and surface to provide data essential for real-time weather analysis. Storm chasers rely on this information to plan their chases and stay safe. And they share their observations with weather centers in return.
I wanted to report to you guys, north of Ellicott, we did have a tornado on the ground that lasted about 2 minutes. It was 5 miles north of Ellicott looking west.
A combination of high technology and human eyes is what allows the collection of valuable data on our daily weather.
It's a mountainous storm, and you feel so small. And in that moment, you're part of something bigger than yourself. That the world melts away, and you're in the moment. You're fully living, and that's special. That's absolutely incredible.
For centuries, weather was considered a realm of the gods. Humans observed its power and unpredictability with awe and fear, but still sought to unlock the secrets behind it.
우주 밖은 처음이지?
선배, 저 떠는 거 느껴져요? 두려운데 경이로워요.
이 드넓은 우주에서 내 심장 쿵쾅대는 소리가 가장 크게 들려. 여기서 태어난 것 자체가 기적처럼 느껴진달까.
Today's space weather is favorable for extravehicular activities today with low levels of solar X-rays, solar radiation, and geomagnetic storm indices. The Sun, the largest and hottest object in our solar system. The Sun is the source of all energy in the solar system. Only 1/22 billionth of the Sun's energy reaches Earth, but it still sends the equivalent of a quadrillion nuclear bombs to Earth per second. This energy drives the flow of water, photosynthesis in plants, and affects the atmosphere to create weather.
성공한 거야? 이게 그 상추?
선배, 저 지금 가슴이 터질 것 같아요. 좁쌀만 하던 씨앗이 엄청난 일을 해냈다고요.
이게 얼마 만에 보는 초록이니. 우주에서도 이렇게 생명이 싹 튼다니. 정말 놀라워.
Plants can grow even with artificial light, as long as they have water and air. This is why Earth, with its abundant sunlight, water, and oxygen, became the only planet known to support life. The Amazon, known as the lungs of the earth. It houses the longest river in the world. It's also the Earth's largest rainforest with the widest variety of life. The Amazon's forests help the circulation of the Earth. How? Through these trees.
Quando o sol chega durante o dia, né, a gente tem ocorre a evapotranspiração, ocorre a abertura dos estômatos, a captação de CO2 atmosférico e a liberação de vapor de água para a atmosfera. Floresta em pé é porque uma árvore em si, ela consegue bombear cerca de 1.000 litros de água para a atmosfera.
Water vapor creates another river in the sky. A long ribbon of concentrated water vapor. It's a river in the atmosphere. This river of clouds flows across South America, and when it hits the Andes Mountains, it condenses into raindrops and falls. Then it flows back down the mountainside into the Amazon River basin. Weather is created by the interaction of water, sun, and atmosphere with many different variables added to the mix. Humans have long wanted to predict the weather. That's why they came to this deep forest. In the middle of the Amazon, where external variables are minimized, there is a research observation tower called the Arrow. It's 325 meters in height.
I am active in the Amazon since 2018, studying the different aspects of the Amazon, mostly focusing on greenhouse gases like methane and CO2.
It was built to study the weather phenomena taking place in the Amazon and the role the forests play in the events. A joint project is being conducted by Germany and Brazil.
If you measure air which is measured at 325 meters, which is the highest height, these air particles have traveled really far, and these are giving signals which are indeed representative for the whole southern hemisphere. And these are the data being used by climate modelers, because this is representative for a really large area.
Sensors are installed on the tower at certain heights to measure chemical and physical characteristics of the atmosphere, such as greenhouse gas concentrations and weather data. A research site at the forefront of understanding climate mechanisms and changes. It's perhaps the culmination of the long-standing desire of humans to understand the weather and climate system. The data and samples collected here are aggregated at a center just below. Researchers are trying to uncover the invisible mechanism by keeping a close eye on small changes in the atmosphere every day.
If we measured 4 meters, the CO2 is really high, while at the highest height the CO2 is really low. This is because the forest is perspiring, the CO2 is coming out, stays close to the soil, while up at the highest height it's already well mixed.
The data measured here is shared around the world and used for weather-related research and forecasting. To obtain the data needed for weather forecasting, humans have ventured even in the harshest lands. Svalbard, the northernmost limit of human habitation. At this knee-elevated research-based village, where scientific bases from over 10 countries are located, there are people who study the weather.
We are doing the weather sonding every day. We have a certain time window when we have to do this. So it's from 11 to 11:15 UTC.
A radiosonde is a device with sensors that measure temperature, humidity, and pressure, as well as a radio transmitter that sends data back to Earth. It's launched into the sky with a balloon attached to it. The radiosonde plays a role of transmitting observation information from the upper atmosphere to the ground.
So the balloon goes up to 30 kilometers high, and then we get also information about the temperature all the way up, the humidity, and also the pressure. And it's very important that we actually do these weather balloons because there aren't so many stations around Spitsbergen who are doing this. So we are a very valuable point of doing these radio sondes and producing data for the weather forecast.
Research continues in the Arctic Ocean, even in the middle of winter. It's a difficult journey that requires breaking through the ice with an icebreaker. The researchers set up a temporary research station on the frozen sea and prepared to launch a radiosonde.
오래 못 버티고 금방 날려야 될 것 같은데. 아, 이 무거운가 보다.
It's a valuable opportunity to obtain weather information from areas that are far from human reach. Now, the wind needs to help.
바로 날려야 돼. 네. 오케이.
파킹 보스 파킹. 예. Go. Whoa.
The radiosonde needs to rise into the sky with the help of the wind for the launch to be a success.
So you can see now the antenna is now transmitting the data to the computer. So I can watch it now until it actually bursts.
Radiosondes are launched every day at the same time worldwide. There are about 1,300 observation stations registered with the World Meteorological Organization. South Korea is also part of the network. Balloons are launched at fixed times, both on land and at sea. The balloons rise up to the edge of the troposphere, transmitting data collected at every altitude until they burst. The information transmitted from the upper atmosphere is shared in real time through World Meteorological Telecommunications Network and is used for weather forecasting.
필요한 건 두 가지예요. 관측, 초기값을 정확히 아는 것. 두 번째는 방정식.
National weather agencies around the world use numerical weather prediction models to forecast the weather.
이게 바둑판처럼 전 세계를 나누고 각 점마다 방정식을 푸는 거예요. 풍량, 풍속, 기압, 습도 이런 것들을 넣고 방정식을 풀게 되면 예측치가 나오는 거죠.
To forecast the future weather, numerical weather prediction models divide the Earth into a grid of small cells, solve physical equations, and then calculate how the weather in one cell affects the weather of the neighboring one.
자연현상을 방정식으로 표현했다고는 하지만 아직까지는 우리가 인류가 모르는 국내외 그리고 가까운 미래에도 밝혀낼 수 없는 방정식들이 있기 때문에 예보관들이 이거를 해석하고 분석하고 그간의 노하우를 통해서 이제 보정하고 최종적으로 예보를 생산하게 됩니다.
여러분, 제가 또 날씨 덕후잖아요. 날씨 예측이란 무엇이냐면요. 여기 악보가 있죠. 이 악보를 손에서 놓으면
Here in space, there is no gravity, which is why we're floating. But what if we were on Earth, where gravity exists?
이 종이가 바닥 어디에 떨어질지 예측하는 것을 날씨 예보라고 해보죠.
Even dropping a piece of paper from just a meter high and predicting the exact landing point is difficult. This is because various physical forces are at work even in this small space.
날씨를 예보할 때도 그렇습니다. 기상 전문 기관에서 수치 예보 모델과 슈퍼컴퓨터를 작동해 예측값을 내놓습니다. 인류가 가진 최첨단 기술을 동원하죠. 하지만 그렇다고 해서 날씨를 완벽하게 예측하기란 사실 어려워요. 수많은 기상 변수가 상호작용하면서 변화무쌍한 날씨를 만들기 때문이죠. 날씨 예측이 힘든 이유 아시겠죠?
Utsira, located at the western tip of Norway, is a small island village with a population of about 200. Hans runs a restaurant with his wife here. But he has another job, his real job.
My name is Hans van Kampen, and I work as a weather observator in Utsira, on an island in the west of Norway.
The island is home to a lighthouse that stands as a testament to Norway's history of weather observation.
Well, this is a weather station that has been there for a long time. It was established in, I think, 1866 or 1867, so that's more than 150 years ago.
The weather in Utsira is a barometer for the weather on the Norwegian mainland. This is because the clouds and wind that originate in the west of Utsira move eastward.
All this time, weather observations have been made here by instruments and by visual inspection of the weather.
The islanders have been observing the weather for generations. Hans observes the clouds 6 times a day and sends the data to the Norwegian Meteorological Institute.
The weather information I collect is just the visual information. I have to write a report on how many clouds there are, what kind of clouds there are, how high up they are, and how long you can see.
Weather forecasting started from the people's eyes that gaze at the sky with wonder and curiosity. In 1854, the United Kingdom was the first country in the world to establish a national weather service. Over the past 170 years, the field of weather forecasting has undergone tremendous advancement.
We've seen continued improvement in our forecast accuracy over the past few decades. So our 4-day forecast is now just as accurate as our 1-day forecast was 30 years ago.
The Met Office houses an archive that showcases the very beginnings of weather forecasting. This barometer was designed by a man who played a pivotal role in transforming weather prediction into a science. He was the captain of the famous HMS Beagle. Sailing around the world, this man figured out the connection between atmospheric pressure and weather patterns. He's none other than Robert Fitzroy, a British naval officer and the founder of the Met Office. In 1859, Fitzroy proved that a storm can be predicted following a tragedy in which the Royal Charter ship was driven by the storm, resulting in a devastating loss of lives.
So we're looking here at one of the charts from the Royal Charter storm, and this shows the weather during the night of the 25th and 26th of October, which was the storm.
Fitzroy's weather analysis chart, which showed the course and intensity of typhoons, played a crucial role in dispelling the prevailing notion that weather forecasting was nothing more than superstition.
Fitzroy, the founder of the Met Office, argued that he could have forecast for this storm and he could have warned for this storm so that the Royal Charter, in this instance, could have gone into harbour and not been sunk. And the same would have been the case for a number of other ships.
The following year, storm forecasting was initiated. Fitzroy established a warning system that drastically reduced the damage caused by natural disasters. And in 1861, he made history by publishing the weather forecast in a newspaper for the first time ever. A concise one at that 23-word message in 4 lines. But it marked a groundbreaking beginning. 61 years later, another revolution took place. British mathematical physicist Lewis Fry Richardson developed a method of weather prediction based on numerical computation. He proposed that by dividing the Earth into a grid and creating a 3-dimensional chessboard, weather could be predicted by repeatedly calculating the equations for each grid cell using observed values and passing the results to neighboring cells. At the time, Richardson's idea was considered impossible, but the advent of supercomputers made it a reality. Today, weather forecasting is done using numerical weather prediction models in every country around the world, and people are provided with the results in real time through the internet. We live in an era where weather forecasts play an integral role in our daily lives.
여러분, 오늘 점심은 김밥과 동그랑땡입니다. 우주에서 어떻게 먹냐고요? 아니에요. 맛있어요. 저희 잘 먹고 삽니다. 점심 후에는 저렇게 커피도 한잔 하고요. 여러분, 오늘 서울 날씨는 어떤가요? 그쵸. 갑자기 비가 내리면 곤란한 일들이 많이 생기죠. 그래서 우리 생활에서 날씨 예보는 굉장히 중요한데요. 그만큼 어렵기도 합니다.
In September 2019, Australia was ravaged by the worst bushfires in its history. The fires, which started in southeastern Australia, spread across the country over a period of 6 months. More than 100,000 people were forced to evacuate their homes and workplaces. Approximately 1 billion animals perished in the flames. The historically hot and dry conditions exacerbated the disaster. While Australia was engulfed in flames, another calamity was unfolding on the other side of the globe in East Africa. From late 2019 to July of 2020, locust swarms invaded an area of agricultural land equivalent to 100,000 soccer fields in Somalia and Ethiopia.
Desert locust arrived yesterday late in the afternoon at 10, but we sprayed in the morning. Still, it's feed all the sorghums which are here and also wheat. So the swarm now I can estimate more than 30,000 hectares.
Experts attribute the locust explosion to unusually heavy rains. During the same period, South Korea experienced an unprecedentedly long monsoon season, which resulted in significant damage. The country's central region suffered the most, particularly with rain persisting for a staggering 54 days. Then, what's causing these unpredictable phenomena? South Korea's first large-scale marine research vessel, the Isabu, travels to the Indian Ocean every year to study the changes in the ocean. Using a device called a CTD, The research team collects samples from depths of up to 6,000 meters below the sea. They lower a rosette of 36 water bottles into the depths of the ocean, capturing water samples from different water levels. Once the bottles are retrieved, the researchers analyze the water to measure various parameters, including water temperature, salinity, dissolved oxygen, and plankton abundance.
표층에서부터 수심 4,000m까지의 그림을 그릴 겁니다. 남쪽에서부터 북쪽으로 가면서 수온이 어떻게 분포하고 있는지를 표시한 그림이라고 볼 수 있습니다.
The temperature difference between the eastern and western Indian Ocean can create extreme weather events. This is because the circulation of ocean water caused by temperature differences affect the atmosphere and changes the climate. In 2019, the western Indian Ocean was 2 degrees Celsius warmer than the eastern part of the ocean.
저도 해양학자로서 굉장히 놀랄 만할 정도로 많은 에너지가 바다에 공급되고 있는 거죠. 그래서 사실은 상식적으로 이해하기 어려울 정도로 큰 에너지지만 어쩔 수 없는 그건 현실이고요. 사람에 의해서 일어난 그런 변화들이 자연에 그런 변화를 끼치게 돼 있는 거고.
Global heating is destabilizing the climate system. Arctic glaciers are melting. In Svalbard, where a lot of science bases from around the world are gathered, there is a 34-meter-high climate change monitoring tower. It monitors climate change patterns by measuring temperature, pressure, and greenhouse gases in the Arctic.
Since 2009 is a very valuable long-term monitoring series of parameters. So we were able to already detect 1 degree rising of the temperature in only 10 years. So the Arctic amplification is pretty much recorded by all the instruments that are installed on the CCT.
Recent research shows that the Arctic is warming at 4 times the rate of the global average. This is causing the boundaries of the Arctic to break down more frequently.
북극 소용돌이는 이제 북극의 중심을 두고 있는 강한 서풍 제트기류로서 이제 북극의 한기를 이제 가두고 있습니다. 북극의 기온이 이제 올라가거나 하면은요, 이제 그 소용돌이가 이제 중위도 쪽으로 이동을 하거나 또 분리가 되고 하는 이런 현상들이 있습니다.
In the winter of 2023, North America and Europe experienced extreme cold, with some areas seeing temperatures drop below minus 40 degrees Celsius. Strong winds caused road closures and disruptions to train and air travel. In South Korea, the Hangang River froze with the feels-like temperature plunging to minus 20 degrees Celsius. An age of climate crisis. The increasing number of variables is making weather forecasting even more difficult. But even with civilization having prospered to the extent of being able to send people to space, Earth is in chaos than any other planets in the universe. thanks to its ever-changing weather. Even advanced forecasting technologies are struggling to anticipate and respond to this chaos. The face of our beautiful blue planet is changing. The weather is becoming a warning from Earth to humanity.
The weather is changing.
The weather is becoming very unpredictable here.
It's a tragedy. Everyone in the Amazon River is suffering right now.